right, matrics, grade 11s, what did we do? We're looking to show that this figure is a rectangle. But now we've just shown that it's a parallelogram. I worked out the gradient. Just to revise a little bit here, if you do take the gradient of AD, it's, remember the gradient of AD, you say 4 minus negative 2 divided by 0 minus negative 6. So that gave me 6 over 6, which was, of course, 1. So we got that gradient as 1. This gradient, if you worked it out, is 1. The gradients are equal. So if the gradient of AD is equal to the gradient of BC, the lines, these lines, AD is parallel to BC. They're parallel. And likewise, we worked out the gradient of AB, this one, is -1, that one is -1. They equal. So again, line AB is parallel to DC. And if these hold true, it must be a parallelogram. You could have done something else. You could have also worked out the lengths of these two sides. And if you can prove that the lengths are equal, there you go. You've got it. You can do that. I'll just quickly run through that a little bit so you can see what happens here. Okay. Okay. So if we move on, ABCD is a parallelogram because both pairs of opposite sides are parallel. You could have also used the distance formula if you worked out the length of AB, and I'm going to rush through this. ABDC, AB is equal to CD, and if you worked out the length of AD and BC, you got that. So the opposite, I'm not going to do it. You can check the distance formula there. Okay, that could work. Okay, now how do we show it's a rectangle? Very interesting. Okay, we've got these points. Okay. I've got the gradients of AB. Now watch this. Now this is important. The gradients of AB was -1. The gradients of AD was 1. Okay. Now when you multiply the two gradients, -1 times 1, you get -1. That's a property that says AB is perpendicular to AD. Okay, so let's look at this if we go to the graph. So we had AB and AD. So we know, and this is the important thing, we've worked it out. Let's just summarize this. The gradient of AB is going to equal, this gradient is equal to 1, but this gradient of AD is -1. And if you multiply those two, if you take -1 times 1, you get -1, which means that that's a right angle. Now, you can literally do the same for all of these, but the thing is, if it's parallel, you'll probably remember from grade 8 days, if that's parallel, these are co-interior, these guys add up to 180, so that's equal, and then these are parallel, so all of these angles will be 90 in the parallelogram, which is now making this a rectangle, which is really, really wonderful. Okay, so we've now proved that this is a rectangle. Okay. Very, very important stuff. Okay, so be careful with this. It's a rectangle because the inside angles are 90 degrees. Parallelogram, and the inside angles are 90, and that gives you, therefore, a rectangle. It is so important. In grade 10s, you're going to need to know this as well. You're going to need to know those properties backwards, and we're going to practice a few properties of those guys in the next lessons to come. Okay, determine the coordinates of the midpoint of the diagonal AC. Okay, so if we draw that little diagonal, we want to get, and we draw that diagonal, we can easily get the coordinates of the midpoints of those diagonals. Remember, if it's a rectangle or a parallelogram, the diagonals bisect. It's the midpoint. Now watch this. If you work out the midpoint of AC, we're showing a property here. The midpoint of AC, you add up the x's, which is 0 plus -3 divided by 2, and 4 minus 5 divided by 2, which gives you -1.5 and -0.5. Now look at that. This little guy there is those coordinates, -1.5 and 1/2. It's the midpoint of AC. Okay, now let's check something else here. Okay, if we work out the midpoint of diagonal BD, okay, we've got that one, we've got that. Now let's see what the midpoint of BD is. Well, okay, -6 plus 3 over 2, -2 plus 1 over 2 gives you exactly the same. Isn't that amazing? And this confirms the property. So now that is exactly the same. Now remember, that was the midpoint of AC, that thing, but this is also, this point is the midpoint. So what can you conclude out of this thing? What do you notice? The diagonals bisect each other at the point of intersection. Okay, that is so important. Okay, so what I want you to do is to master those principles, guys, of midpoint and of distance formula, gradient, all those things. But very importantly, understand the properties of quadrilaterals, parallelograms, rectangles, all those things. They often integrate that into the exam questions, as you see with this one. So stay with us, and we'll come back and do some more wonderful maths on Matrix Uploaded.